I'm in the garage, I'm starting a job, and I'm finally going to do something that people have to do all the time. And what I'm going to do is, I'm going to finally send out pictures of a knob that people have to It's actually just David Savoury asking for those pictures. Hey, cocksucker. Cocksucker, you know your name. But anyway, people always ask me, people ask me like, how'd you get to do what you're doing, or how'd you do what you do and stuff. And one of the things they ask a lot is about what I do is, they ask about PLCs. Well, these aren't PLCs. These are these are baby PLCs. These are called smart relays. So whereas a PLC can control a whole massive system and have thousands of inputs and outputs and all that bollocks, yeah, these are called smart relays. And they do it with the 710. They're smart relays. They can replace groups of timers, relays, and other like controller type bits with quite a basic I/O and software structure. So over the next few weeks, and what will no doubt become a YouTube video, because this video is sideways, I'm going to take you through the process of what I'm going to use these for, why I'm going to use them, how I'm going to use them, and why I chose to use them in the application that we get to see tomorrow, which is the refurbishment of a barrel washer, why I'm going to be using this and how it helps. So as well as that, last night someone asked me, like, how can I do what you do, yeah? First of all, go on eBay or go to an old maintenance department like that, or somewhere, and find an old RS catalogue that's made in the last 10 years there. It's future in the edit me. This is what I'm on about. The RS, I think it stands for Radio Spares, but that one. Yeah, this is the oldest one I've got from 2015. This is a small one. They used to go in packs of 5. I put this in the video. Turns out these are like rocking horse shit. I can't even find one on eBay. Now, I was going to buy a fucking set of 5 before I told you all about it, because people no doubt try and buy them and put the value up. But yeah, if you try and find one of these kicking around at a flea market or something like that, but seems like people just throw them away now. I've kept this old legacy one just because a lot of classic things don't go out of fashion. But yeah, good luck getting one. Sorry about that. I hope I got your hopes up. This one's mine. I'm keeping it. Then sit there one night and flick through it cover to cover and work out everything that's available. And one thing you can do is, these there's various types of these smart relays kicking around. This Crochet, these other ones, I think they're all made by the same people. But this particular one that I'm using is a Zelio by Schneider Electric. So the good news is for everyone is you can download the Zelio software for free and you can make your own programs. I think you might even be able to simulate your own programs. So you can buy one of these. They're not that expensive, but don't buy one yet. But do download the software, which I'll put a link up for because I'm going to find it myself. And what we'll do is we'll have write a bit of code in it before the project's done. So yeah, Zelio by Schneider. The software is free. Hopefully there's a simulator as well. Anyhow, we're sideways now, so it's time for some actual electrical content with this. So this is what we're going to control with the smart relay, the smart PLC thing. So this is what is going to get automated. So what I'm going to do is, we've talked briefly about smart relays. Well, I introduced you to smart relays. At some point, or it might already be in this video if this video is on YouTube, I'm going to talk you through smart relays, the software, the ins and the outs and all that. That might have already happened if this is YouTube again. But for now, I'm going to talk you through this glass wash. And what we're going to do is we're going to go over the process that's involved. Because without the process, there's no automation. If there's not something to automate, we can't automate it. And we need to know what the individual functions of this device are and how they interact with each other and other things that may be added to the process. I'm going to go over that now. And you can start thinking about how you would control this and what things have got to be considered. So everything you're going to automate as a process, as things it's got to do, and it's probably got things it's got to do in the correct order and sequence, which is what we're going to go over here. So I'm going to show you what this is, what it does, and then you've got to start thinking about how that would work in code for a start when you get the PLC. But you've also got to start thinking, what other control gear do we need? How are we going to switch this thing down here? How are we going to do that? So let's have a look at the process, or what the user wants to do. So it's a keg wash. It's for washing kegs or beer barrels, as you might know them. And it's got 2 major components. It's got a pump down there and it's got a heater over there. They're the 2 major bits. That's it. That's as simple as it gets with what's actually on the skid. And the concept is the user comes along, puts a barrel on here or a keg, puts a keg or a barrel on here, presses a button and off it goes. And it will take hot water from this tank that's been heated up by that element, and it will suck it down that hole just there, take it through that pump, and it will jizz it out of these little jizzy ends into the barrels to clean them with some caustic soda in there. Now, the things to point of note here is that both of these
are connected together. You can't put one barrel on it, you can only put 2 barrels on it. So that throws up its challenges. So simply put, it needs to be at 70 degrees. You put the barrels on, you press go, it washes them, and it tells you when it's stopped. So on the skid, there's a pump. There is an immersion heater, 3-phase, 12 kilowatt, with that's like a stat. We won't be using that, we're using digital ones, but we will incorporate that as an emergency, it's fucking too hot stat. In here, you've just got the other end of the immersion heater, and you've got these pipes, that's it. So there's not a lot going off, or you wouldn't think there's a lot going off, but there's a lot more to it than what's on that skid. So just off the top of my head, a few things to consider are, first of all, you see these nozzles that clean the barrels, you've got to have 2 barrels on. You've got to have 2 barrels on here. Otherwise, if you put one on, the other one will still jizz water out. We're not going to put any valves on to stop that. That's how it's going to be. So we need to be aware that there's 2 barrels on there, or we need to get the user to acknowledge that there's 2 barrels on there. So the options are, and keep this simple, not going too deep, we could have sensors that detect a barrel. So it could detect when there's 2 and only allow the pump to run then. The problem is some barrels are made out of metal, some barrels are made out of plastic, so detecting them could be quite difficult. We could also have a button here where the user acknowledges the barrel's on, steps away from the machine to press a button on the control panel, so if it does jizz out, it doesn't go everywhere, but we all know that's going to go absolutely everywhere. So that's the big consideration that I'm dealing with. Let's talk about the water. Water-wise, it will have, for the first wash, when they've been full of beer, it'll have caustic soda in. So that needs to be heating the water to 70 degrees to activate the caustic and kill any germs that are in this. So we want to maintain around a 70-degree temperature. We're not going to do it with that shitty little stat, because that shitty little stat doesn't tell us anything. It's just like, we're going to use that as once it goes over 75, that's going to cut the control system off. That's what I'm going to use that for. And I'm probably going to buy some really cheap digital displays you can get off Amazon for like a tenner each that'll do this. And I'm going to double those up so that I get double redundancy on my heating hot water. That will also have to be switched by quite a large contactor. The pump down the bottom, it's going to need a dole starter for it and motor protection and all that. So there's a lot to go at, and then we want to automate that all. So let's just look at a few bits that I want you to ponder if you're watching this video because you want to do PLC stuff. So if you're watching this because you're into the PLC side of it and you want to get involved with the process, which is going to be going off over the next month or so, Jays, what is the process? Draw the process, the flow chart, yeah? And then what are the problems with that process? Where could things go wrong, like not putting 2 barrels on, not having the water hot enough? And now we're going to cater for that. The second thing is, what's the human-machine interface going to look like? This has been done for my mate. We're not spending loads of money. We're not spending 10 grand on this. There's not going to be a touch screen. There's going to be a button panel, and it's going to have push buttons on, and it's going to have lamps on. So like, I don't know, you'll press heat the water, and a lamp will come on to tell you the water's hot enough, and that the next part of the process can begin. So we've got to work out how that's going to work and do some sketches on that. So one, how we're going to interface with it. It's going to be push buttons. We're going to control it with a smart relay and traditional contacts and relays and stuff like that. And the other thing we've got to consider is, how is the human user going to interact with it safely without getting jizzed on with a load of hot caustic? So there's quite a bit to go at. I've shown you around it, now we're going to go on paper. So that's it on that. I think I've covered everything. I've absolutely covered everything. One thing I will say is I'm going to probably put a junction box down here and have the control panel remote. Like, it could be next to it, it could be a mile away, but it's going to be remote. There'll be a junction box on there. So now it's about going on paper and working it out, drawing the push button station, how that's going to interact with the user, thinking about what control gear we're going to need inside the panel, thinking about what I/O we're going to need on the PLC, the inputs and the outputs, and how that's going to work and what order that's going to work in. So probably the last video I've done on this today, because I'm not going to get another chance, but I just want to show you it. So if you want to play along at home or play along in software with the Zelio stuff I put up the other week, which is not on YouTube yet because it'll be part of this video, we can go through it together. So yeah, that's it. That's how it works. Any questions, drop me a message. I'll try and answer them if you want to play along at home. If that's 3, yeah, fuck it. We'll play along with 3 of us. So yeah, that's my little automation project I've got to fill the gaps this month. I know why you're here. You're here for some... Oh, my hands are here. Actual electrical content. Hopefully. So I'm on with this barrel wash, yeah, but I need to go over all the bits and bobs. So this is... For all intents and purposes, it's a PLC, but it's not, because it's not advanced enough to be a PLC. It's a baby PLC. It's called a smart relay. And the reason is it's called a smart relay is because it's many, many relays inside,
and it's smart, as in you can automate it with a program. So everything you're going to automate requires inputs and requires outputs. And that doesn't matter whether it's a smart relay, a PLC, a Raspberry Pi, a washing machine, a toaster might even have a little tiny microprocessor into it. Yeah? So these range from interjection, everything I've just said there is a processor, which is sometimes what we call PLCs, processors, or a microprocessor, a microchip, a smaller processor. So they're all exactly the same, as I alluded to. But I just thought I'd put that in, that we sometimes call the brain of the PLC the processor, and everything else is a mini version of it, a microprocessor. Microprocessors, microcontrollers, which are little tiny chips that are capable of handling in and outs. In the middle, you've got smart relays, which are capable of handling in and outs. Then past this, you've got PLCs, which, I don't know, could be like factory-wide, hundreds of them, all working from the same code. In anything you want to automate or control, you've got to have ins and you've got to have outs. And there are various different types of ins and there are various different types of outs, yeah? But I'll show you the ones that this is capable of handling, and then we'll talk about the other options. So on the PLC, I've got a close-up one here. Got two, so I'm mad pimp, yeah? Let me show you the top. So up here, look, you've got the L and the N. That's the live and the neutral. I'm going to put a screenshot of this up here so you can follow along at home, yeah? Because it's better than fucking around back and forth to the camera. But at the top, you've got live and neutral. And below it, it says 100 ... 240 volts AC. Because this smart relay, this one I'm holding in my hand, is capable of handling 100 to 240 volts. Because the place I got these from, we used to use 110 volts AC for our control box. Oh, I'm going to have to read that now. We used to use 110 volts AC for our control voltage, and that's why these are in that range. So that's why these are in these ranges. This particular range, this is the Schneider one. Yeah, but I believe they're also made by Cruzet and another people. You'll notice they look the same. I think they're all made out of the same factory. I think if I do that to the video for you. But this one's a Schneider one. This particular one is a SR3 B26 1FU. If you want to look it up, play along at home, be my guest. I do believe that this one cannot handle any additional things on the side. And I think this one up here, oh no, look, they have. If you look up here, look, here's a little baby one, little tiddler. Yeah, it's got a little box up here, look, and I believe that's where you add on additional modules. So you can get one of these and you can add modules on that make it bigger to increase the amount of I/O you've got, or increase the type of I/O. But anyway, let's talk a little bit more about this one in particular. So, first of all, you stick live and neutral in here. So let's say we're going to use 230 volts. That's what we're going to use on this barrel. We're going to use 230 volt control. Because I'm not mass producing them, there's no super requirement for safety. It's RCD protected. I'm just going to use 230 volt because it saves me fitting a power supply or a transformer. But we'll get to that later in this series, yeah? So you put live and neutral in. This will light up, but it won't do a fucking thing. It's just a dumb box at the minute. Along the remainder of the top, you've got the inputs. And they go from in 1, in 2, in 3, in 4, in 5, in 6, in 7, in 8, in 9, in A, in B, in C, in D, in R, E, in F, in G. So there's however many that equates to in numbers. The last terminal is just an empty spare terminal. They're the inputs. They measure voltage between 100 and 240 volts AC. So if you put voltage into them, it will see it. How it interprets that voltage is up to the software, which we're going to cover later on. Just to touch on that, in all those inputs, when we put 24 volts, when we put 240 volts in, you put 240 volts in, the PLC sees it. How it acts on that 240 volts, being there or not being there, is entirely up to you in software. But all the way on the top anyway, it's full of inputs. At the bottom, we've got the outputs. These are labelled Q1, Q2, Q3, Q4, Q5, Q6, Q7, and Q8, Q9, and QA. Q8, Q9 and Q8 are a little bit different, but I'll show you the first ones first. Again, there'll be a picture on the screen. These 1, 2, 3, 4, 5, 6, 7 are dedicated contacts. So you put a voltage in here and there's a switch, and the software makes that either open or closed. So you put a voltage in there and there's a switch. You could use 230 volt for that one, 110 for that one, 24 volt for that one, because they are isolated. They are contacts, pairs. Normally in the PLC game, we call those contact outputs or isolated outputs because they are just a switch. And they obviously, whatever voltage you put is what voltage you get out. Q8, Q9 and QA have got a common. So you put a common voltage into the C on that, and then when you switch it, it will switch on Q8, Q9, or QA in any configuration. All of them on, all of them off, and anything between. But if you want to use, for example, to a lot of some 24 volt lamps, and you've got 3 lamps, you can put 24 volt into C, and you can output it on them. So it's not super difficult. It's just a series of switches on individual contacts, 3 switches on a multiple input, on a multiple feed, and then on the top you've just got ins, and that is it. That is all a smart PLC is. It's nothing clever about it. Like I say, once you put voltage into it, it lights up, and the magic is inside that this can take an input, whatever that input may be, and provide an output. This particular smart relay, not the range of them, just this particular one, can only handle digital inputs and outputs. That means an input is either on or off, and an output is either on and off. Those can be various voltages, whatever you want to play with. So you can get a 24 volt one and put 24 volts into it. You can get a 231, 100 volt like this one and put 110 volts into it, or whatever, yeah? But all it sees on the input rails is it's on or it's off. It's as simple as that. That's digital. It comes from the 1 and the 0 that's using the code. 1 being on, 0 being off. What you do with those inputs is up to you, but it has only got digital inputs. Again, on this one, it's only got digital outputs. They're either on or they're off. Okay, they're isolated as individual pairs, except for the ones at the end, which are common with 3 outputs, but they're either on or they're off. That's what digital inputs and outputs are. Ons or offs. I'm really reiterating this. Digital output is 1 or 0, on or off. The next common one that features on extension cards to this PLC, but isn't actually on this PLC, is analog. And analog is a proportional value. I think on these particular smart readers, it's 0 to 10 volts. That being the span that you could operate with. On bigger PLCs, and maybe on this range now, there's also one called 4 to 20 milliamps. I've got whole videos on this if you want to have a look. I'll try and put a sticker to one up here if it's on YouTube. But they are spans, so 4 to 20 milliamps, 0 to 20 milliamps, 1 to 10 volts are spans. And for example, like I said, I've got a video on this, you might have a tank and it might have a sensor on it, and that sensor is also analog, and it decides that when the tank is empty, it's 0 volts, and when the tank is full, it's 10 volts. And that can then send a signal between 0 and 10 to this PLC, and this PLC can interpret that as being proportional values. Either it's empty, it's full, or where it is in the middle. That is analog I/O. That wraps 95% of the I/O up. Digital in and out, analog in and out. Obviously on an analog in and out, it outputs the value as a proportional thing to tell out now. Like a graphical bar to change something like that, whatever, it doesn't matter. There are also various other inputs and outputs you can get. Things like this specialist though, then after that, like thermocouples. It being able to accept a thermocouple, which is a temperature device directly. Temperature devices like thermocouples come in loads of different types. It's like PT100s, Type K, Type J, Type I thermocouples. But there'll be dedicated cards for handling a dedicated sensor. For example, thermocouples, PT100s, maybe like a Profibus card, a communication card, an Ethernet card. I'll look in the catalogue and probably put some pages up here and tell you a bit more about them. But they're the other inputs and outputs you can take. But at the base of it all, it is just about analog in and out and digital in and out. And in the case of this project, it's going to be digital in and out only. In this project, we are going to deal with the temperature. And this PLC will need to know whether it's at the right temperature. So to do that, what I'm going to incorporate in one of the next videos is I'm going to use a digital readout. That digital readout has its own PT100 sensor. It handles all the thermographic stuff within itself, and then it sends it as a relay in it basically. So this will send it will be a voltage going into that thermometer. When it hits 70, it will energise, and it will send a digital input to this to say, I'm hot enough. It's not worth the money on this project to buy a PLC that can handle temperatures, because it's just too much cost for what is a very basic process. So the PLC is capable of taking values as ons and offs from other more clever instruments into itself and use that in the code. So that's about it. That's all I can go into really. What we'll do next is we'll have a look at the code and how the code is written. We'll write some basic code and I'll show you the simulations you can do. Now, if you watch on YouTube, that'll be the next part of the video, the next part of the video. But if you watch on Instagram, that won't be for ages because I'm still getting around to this. But if you do want to look into these, they're called smart relays. These particular ones are made by Schneider, and their range of smart relays is called Zelio. Z-E-L-I-O. ILO. Look at the catalogue, look at the inputs and outputs you get. I know some people are playing like home, yeah. To get this to work, you need one of them, which I think you can buy on eBay if you really wanted, or any of the brands, the Cruze ones or anything like that, yeah. You can just buy on eBay. If you want to get into PLCs, these are a great way to start. I made a little plinth for this one, look, and I'm actually making one that's got switches and lights on it, yeah, so I can play with it. These are not expensive. I think these are like 100 quid-ish. This little one's definitely 100 quid. This one's a bit more. You need the data lead that plugs into it that goes to USB. The software and the simulation, all that is absolutely free. You can play around with that now. So don't go out and buy one if you don't need to. You can just use the software. But yeah, if you want to get your hands on one, make some traffic lights for your train set. You can look at the catalogue and pick one up. So that's it on Smart Relays for now. This is the ongoing project of the keg wash that I'm doing for my mate. A job I've really only accepted so I can get a load of YouTube content out of it, because it's interesting to follow along and he's not in a rush. But yeah, the reason I've chose to use a Smart Relays, I get adjustable timers because it can act as timers as well. Within here, we'll be able to have about 30 timers if you want, which is going to come on the software stage, which could be a whole video in itself. So hold to your hats, Peter, that's going to be a really exciting one. But yeah, basically, it gives me a bit more flexibility than using relay logic, but also it cuts down a lot of relays and costs. It actually, there's a point where you're putting relays into panels, as long as it's not safety critical, where it just becomes more convenient to buy one of these for a couple of £100 and stick it in, and then just wire everything to it, wire everything out of it, and then sort the software out after. So for example, let's just briefly go over an example. Let's say your kettle's got one of these in. You can do this with anything like a toaster or a microwave or a wash, but let's just say the kettle's got one of these in. Not really a kettle, but a kettle-like thing, yeah? In the kettle, you have a temperature device that when it gets to 100, closes the relay, puts a voltage into here. And then coming out of here, you have power to a contactor that energises the element. Then you have a button that when you press it, it starts the process. So you've got a button in, a temperature in, and a coil out. You walk up to the kettle, be more like a tea urn. You press the button, this comes on. Then this says to the thing, oh, I've been pressed. Turn on the element. So it turns on the output that turns on the element. Then the element heats the water, and after a few minutes, the temperature gets to pop in. The temperature gets to a high enough level that the temperature device is satisfied. It then says to this, I'm hot enough, and that goes okay, and it cuts off the power to the coil. Then it resets itself and waits for the button press to be pressed again. Very simple solution, very simple bit of software, but it would be achievable to do. So that's what they can do. That's the actual bit of this content done. Like I say, it's going to a YouTube video. If this is on Instagram now and ask questions, there'll be a question box up there for you to ask questions about PLCs. I'm not fucking super duper PLC, yeah? I know how they work. I can fault find on them, and I can program little baby ones like this, and I can fault find programs, but I don't write raw code for like entire factories. But I'll do questions on here. If you're on YouTube, you'll see those questions pop up in my answers, because there'll be video things on here. So yeah, I'm tossing it off the rest of the evening and tomorrow. So if anyone's got any questions about PLCs, don't fucking start asking me like really complex ones. But if you've got anything you want me to cover in this series or like that, stick it in that box. Anyway, go fuck your mother.